Good morning. Welcome to day 2 of the Software Effectiveness Conference. My name is Matt Peloquin. I'm the CTO at Construx, and I put together a presentation today called Code in the Wild, which gives some perspective on the work that we do reviewing design and code for technical due diligence. So our code and design reviews are something we've been doing for over 10 years now. There's various reasons why we do this work, but most of our customers have been looking for technical due diligence help. So that's software companies that are buying other software companies, and also organizations like private equity firms that want to acquire a software company or make an investment. So the stakeholders in these reviews may be very technical or not so much and are looking more for business risk analysis. We also do internal reviews for customers. So in some cases, organizations just want to see independent review of code. In others, there may be concerns about a project. And in those cases, we get to see a wide range of software. In some cases, with internal reviews, we see very good software that's been having project management problems. And in other cases, we see software whose design and code could use some help. On the technical due diligence side, typically companies that are being acquired are successful. So we don't see companies that have failed because of software, but we still see quite a bit of variance. And in terms of what sorts of software we see, there is a wide range of technologies, what the software is built for, very wide range of histories, anything from very young to very old, and the size can vary significantly as well. So the exposure we have to the industry is not anything that I would consider representative of the industry as a whole, and certainly not a random sample. So the insights we're sharing here are really focused around our experience and work, which does have a broad coverage, but certainly I wouldn't characterize it as covering the entire industry. In particular, we don't see the code of Facebook or Google and so forth. So very large platforms, very large organizations are not what we're looking at. In terms of what we consider during the analysis, we are not testing the software. We're not looking at the functionality. And as part of that, we also do not do security testing or auditing, which is a big specialty area. So we are doing a static analysis of the source code with tools and visual inspection and understanding the design of the software and getting into development practices around the software. But no penetration testing, no looking at functionality and features or feature analysis with the marketplace and so forth. The nature of these reviews are, first and foremost, very confidential. Obviously, in any of these arrangements, particularly due diligence where multiple parties are involved, we are protecting the intellectual property of the software for the folks that are selling it. So there's very little that we can share in terms of specific examples and so forth. And in many cases, we have to destroy the work products that come out of the review. So we don't have we don't have examples in this presentation, and don't really have specific code metrics that characterize particular areas of code. But we will talk a bit about how code metrics can be used in the process to help ascertain code quality. We've been doing this for quite some time. I've been focusing the talk on last 5 years or so, because obviously software is always evolving, and what may have been interesting 10 years ago, not so much now. So many of the observations that you'll see here are predominantly related to the last 5 years. In terms of the types of software, all sorts of things. Because of the nature of our work, we tend to see a lot of what I would call vertical market platforms. So it's always some type of significant custom investment, but what the platform is doing can vary quite a bit. And obviously these days, pretty much all softwares that we see is hosted in some form or fashion. Even 5 years ago, we'd see a lot more desktop applications and so forth. But now everything, to some extent at least, is hosted. Even we look at sometimes at medical devices and so forth, and even there now, you quite often see devices that have the code on board and embedded software, obviously, but then there's still some type of hosted component for data collection, control, and so forth. So that has been a big change in the last 10 years or so. And for most business systems these days, you can just assume that it's going to be a fully hosted system, and quite likely in the cloud, which we'll talk about as we go forward here. The size of the systems we see varies quite a bit and correlates strongly with the age of what we're looking at. So our sweet spot of what we normally see is somewhere between 100,000 and 1 million lines of code, but we do see outliers, sometimes smaller and occasionally quite large, 5-10 million lines of code, which are usually from large 30-plus-year-old code bases that have just been accreting over time and a bunch of acquisitions, putting stuff together and so forth. So you can end up with quite a lot of disparate code, or the types of reviews that we do. Most of are a single system that has been built in roughly the last 5 to 10 years and is dedicated to supporting a particular core business infrastructure. We see all sorts of languages and technologies, and we'll be going into that a bit later. But the way we've built our capabilities and our value proposition to our customers is that we can handle pretty much any technology, since we are technology agnostic. And what we're looking at, because we don't look at the functionality and feature, we're really looking at general software engineering best practices, which can make us a one-stop shop regardless of the technology nature of the deal. So in terms of the types of groups we've worked with, and I think this is important because in our experience, Conway's Law is not a law, but a saying a guy came up with about 20, 30 years ago, I believe, which is that a system resembles the organization that built it. And our experience is that this is 100% correct. Whenever we see a code base and a development group, there are very strong correlations between the way the system is architected, its organizing principles, how code is maintained, and so forth, that tie very strongly back to how the team itself that built it is organized, how big it is, how they break up their teams, how they break up the work, and the types of processes they use to create this code and systems. Now, that's not to say that these systems are all nice and clean and coherent. In many cases, we see code bases that have been growing for 10 years or more. And you can imagine there can be a lot of technology change over that period of time. But you also see significant changes in team makeup and the practices that the team may be using to build the software. And that obviously has a big impact as well on what that software looks like, because you can have parts that are older that look far different from parts that are newer, even if they're using similar technologies. The dev size of most teams is somewhere between 4 and 40. 10 to 20 is probably really, again, what we see most frequently. Occasionally, there will be very large dev organizations. And usually once you get over 20 folks, there's some sort of breaking up of the dev team geographically. And most of the very large teams tend to have some sort of large center of gravity offshore of North America, as well as dev teams in North America. And we also do quite a bit of global work. So we see other dynamics as well with teams in Europe that are often distributed over 4 or 5 geographic locations. So for the fun part, do we see bad code? Yeah, we do. Even though, again, most of the due diligence companies we look at are successful companies that are being acquired, we still come across code that's in them. And maybe not, it's not the entire code base, maybe it's old code, but there's definitely some scary, almost funny, scary code out there. This one example is one of my favorites. I have to admit, it's actually more than 5 years old, but I love the comment so much I had to still use it. And this was actually a real file from a real project, and this was really the only comment in the file that obviously someone had added somewhere and after they had been assigned to maintain it. This is not the norm in terms of what we see. But first, some other scary things that we've seen. I think the longest SQL stored procedure was 30,000 lines, and that's of declarative SQL code. There was an organization that had been going for a long time with essentially a cut and paste approach to a PHP web application. And they had, it was amazing how much code that they had put together. When you drilled into it, you realized that probably 20 times this code had been duplicated almost 20 times. And so all over the place, you'd find similar screens, similar logic, similar objects. So quite difficult, obviously, to maintain something like that. On the configuration management, build and release side, one system we looked at had a very, very high level of granularity across modules. So actually 500 individual modules, but these needed to be composed and collected for a build process on a per customer basis, and they hadn't automated that for some reason. So they actually essentially had a manual checklist to go in and run through and say, okay, we're putting together this build for customer X. We need to grab the latest version of this, this, and this. And a lot of the pieces, they had automated build for each piece, but they might have to go and run that to assemble it. It was, again, probably not the sort of thing you want to see. In general, most code we see does not have client-specific branches anymore. People have figured out that trying to maintain more than one branch of your software long-term is very expensive, but you still run into it. In some cases, a decision may have been made 10 years ago or farther back that the goal of the organization was to create some shared core software, and then there would be a services-based business built on customizing that for customers on a per customer basis. And it actually can sound pretty good as a business because you're getting paid to do the changes to the code for the customers. But the problem is if your business hangs around for a long time, you can end up with quite a lot of customer specific code. It makes it very difficult to evolve that core shared code that you have. And then another favorite we still bump into is seeing violations of layers that most people would take as a given. So HTML being baked into SQL code and the converse embedding, which I think is probably more rare. And Oracle did some stuff for a while that encouraged people with that, with some SQL web forms. But we've actually seen people do it on their own outside of that. And then obviously embedded SQL used to be used all over the place. We're seeing much less of it now, but it still definitely crops up if someone wants to get some data out of the database quickly. So in the cases that there is pain or backing up, I'd say everyone that works in software knows that the code they're working with could be improved. Technical debt is just part of software systems. So all real world software is messy. And you talk to any development team, they've got all sorts of things they'd like to have a chance to do to make it better. And they also have a pretty good idea where the scary bits are, or at least where the areas that they would like to improve are. So this usually isn't a case of a lack of knowledge or experience. It's really just about making trade-offs about what is available in terms of the time and resources. So most organizations are under pressure to respond rapidly to customer needs. And quite often the project management sophistication of the organizations doesn't allow them to make sure that certain fundamental tasks that may not matter so much in terms of short-term shortcuts, that those are avoided, because in the long term, they can end up piling up and creating a lot of technical debt that's a problem. So in terms of our reviews of software, we're not looking for some sort of ivory tower academic purity test. We are very experienced with what real world software looks like. So when we're trying to ascertain business risk for organizations based on the code quality, we're being very realistic about the fact that, yes, the code has all sorts of things that could be improved, but the questions are there some fundamental characteristics of the code that make it less risky to own and maintain long-term than others? And in terms of the pain, both the pain that all software has in terms of trying to improve, and I think the root cause of some of the pain of the horror stories, is really this idea that you assume that you can go back and replace and fix problems in software after it's built. But in reality, you very seldom get the chance to do that. So really what you have to embrace is that your code is going to reflect the way the crucible that it was forged in. And I'm using the word crucible there very intentionally, because there's usually a lot of pressure, a lot of heat, a lot of fires to fight while the software is being built. And what you get out of that, software tends to be brittle. You have to work really hard to make your software not be brittle. And even when you do make your software flexible in some areas, it's still going to be brittle in other ways. So those two dynamics make it very difficult to build software long term. And then the other dynamic is that existing code is very difficult to change. We'll be talking about code metrics in a bit, and lines of code, and we can talk a little bit about whether or not that's a good measure. We use it consistently because it is a measure of size, and size does matter. So if you have 100,000 versus a million lines of code, I don't care. You can argue all sorts of, how was it counted? What language is it? Et cetera, et cetera. But a million is still a lot more than 100,000. And when you have to wade into it and sort things out, it does have an impact on how much you have to essentially assimilate to understand and change the system. So the more code you get, the harder it is to change. And I'm sure most people have the experience. It's you very seldom get a company mandate to go in and rewrite large portions of the code. Usually the best you can do is wrap up the old areas, build some new stuff alongside it. And if you're lucky, you may be able to sunset that after a while. But it's a dynamic that needs to just be accepted and embraced, that code is like concrete. And once you start putting lots of code everywhere, you end up with a lot of concrete. And if you've ever had to break up and move concrete, you realize it's really hard to do. And a lot of times it's just easier to leave it there and build around it. And that's typically what happens in software. So the goal is, if you're trying to build for the long term, to really try to make decisions that minimize the pain when you have to go and continue to evolve the software and build on top of it. Some drivers that we see around the evolution of code, because all code is always evolving. So particularly, the time frame may be a year, maybe a couple of years. For some projects, it may be months. But you're always changing what the software is doing in terms of adding functionality. You may be pivoting or repurposing. Quite often new technologies get introduced, or you may decide that you want to try new things like, oh, let's do some automated testing, and that can drive changes. So there's lots of things that push code evolution. The original technology, we think, is generally one of the biggest influencers. And that's actually what that does is it's more of an inertial weight, if you will, that holds back changes in other directions. But it does mean that you may keep doing something the same way, not because the team thinks, oh, this is the best way of doing things, but just because it is actually the most straightforward way to get stuff done, because that's how all the rest of the code is written. And if we try to do something different, it's going to take time to sort out how the two things should fit together. So we'll just keep doing it this way and keep adding on. I think it's often, you can get into all sorts of religious wars about what technology is best, but from our perspective, just observing hundreds of teams over the years, really a lot of the technical choices seem to boil down to what the team at the time knows and is familiar with, or in some cases, what new sexy thing they want to go try out is. Generally, that team dynamic has a huge impact on the technology selection. And in many cases, and that's good because you don't want to keep pushing a team into having to learn new things that aren't really going to provide much value. But you also don't want to become complacent and just keep doing the same thing over and over with the same technology just because the team is comfortable with it. On the flip side, you don't want to hire someone new and say, oh, okay, we got to switch all of our web UI over to Angular now just because we hired someone who thinks Angular is really cool and pointed at a website and say, oh, look what we can do. And say, okay, yeah, we'll go and rewrite everything to do that. It's better to make those decisions about technology based on, business value and look at long-term decisions about where it's worth investing in writing all the code that's going to go along with that technology. Another dynamic we see influencing the organization of code, how it's written, what it looks like, are best practices. And I think definitely in the last 10 years, and especially the last 5 years, you've seen that have a big influence on some organizations' code. I think probably one of the best examples would be Airbnb's JavaScript standards that they started publishing quite a while ago. Have essentially been, and again, people will argue one way or the other, but that's I think a great example of, we see a lot of code that has just decided, oh, we'll adopt this approach to organizing JavaScript, because obviously there's a bazillion ways that you can write JavaScript code, and there's really no benefit to your organization coming up with a new one. And those types of best practices and approaches to software can be very powerful, I think, for the industry, but it also helps so a team doesn't have to reinvent the wheel constantly. We'll talk about this a bit more later, but there's very little gets written down with software projects. And there's always been a long history in software of people wringing their hands about a lack of documentation. And 10 years ago, people felt guilty about it. I don't even think I think people flaunt it these days. However you slice it, what that means is that software teams have a heavy reliance on tribal knowledge. So that means that the team has a bunch of knowledge shared in their heads about how the system is organized, how it works, its design, its architecture, where code lives, and so forth. And that does influence how the code itself gets written and shaped. And that can be a positive thing in terms of encouraging modularity and organization. Or in some cases, if you are inheriting an old code base that has evolved beyond what people remember what the organizing principle was supposed to be, or just wasn't very good, it can actually be very painful because no one knows what half the code does and why it's there, where it lives, and so forth. So in our experience, you can be successful with tribal knowledge and not successful. And it's almost not even an argument, because outside of open source projects, which are forced to share information across time and across people, then can't rely as much on tribal knowledge. Business organizations these days very rarely, and I mean 1 out of 30, have what old folks would call comprehensive design documents. They're relying on tribal knowledge and primarily the code itself to document what's going on. And obviously, there are many successful companies, and software is growing crazy. So you can definitely be successful with that. But we do see some best of breed organizations that they're not trying to document everything, because that, I think, there's just no business value there. But they do figure out that capturing some high leverage information can be very powerful. And then obviously, everybody's agile and doing something scrummy these days. We have not seen a team in the last 3 years, about 60, 70 teams, that didn't claim to be doing something that was based off of Scrum. What exactly that is, we honestly don't get into it that much in these reviews because it's just not that interesting, because it'll always be some type of iteration and backlogs and so forth and so on. What we really care about is how does that manifest in the code and the code quality. And don't really see much correlation between the nature of the process, the agile processes being applied, and the quality of the code. So even though there are these pressures such as rapid iteration going through the code that would cause pressure to make a lot of short-term decisions, we've also seen organizations that plan things out on longer time cycles and still can write code that has a lot of problems. So it really seems to be more about teams or individuals on teams having vision and leadership about what decisions we should make around structuring the code, and how we avoid falling into going down short-term cul-de-sacs that'll make it very difficult for us to extend and maintain this code, while at the same time being very responsive to customer needs. And one of the best practices we've seen around that is making all work show up in the backlog. So that includes technical debt. If you need to do, for instance, architecture, exploration, prototyping, and so forth, that has to go in the backlog, and it has to be prioritized against other feature work. Automated testing has to be in the backlog. Otherwise, it doesn't get done. So that's just really a reflection we've seen of what makes organizations more successful in terms of producing higher quality code. So during our reviews, they're usually driven from particular questions about the software system. And again, some of the folks that we are creating the reports for are very technical and have very specific questions and concerns about the software. Others just don't know anything about software code. But even so, the 5 questions that are here are some of the most common ones that we'll get. So scaling is big because everybody wants to grow, and so the software needs to grow with them. And in particular, when someone's acquiring a software company, they usually want to grow it. So that's always a big focus. Obviously, the last 5 years, there's all sorts of questions about the cloud, and it doesn't matter whether it's someone with a technical background or not. Obviously, there's different, pretty much depends who's asking the question in terms of what they mean by will it work in the cloud, or isn't it in the cloud, or is it cloud native, and so forth and so on. So we'll talk about that a bit. Maintainable and documentation. These two obviously go hand in hand and related somewhat, but we look to separate them because, again, we see you can have very maintainable code and very successful and sophisticated organizations that have decided consciously not to document. But it still often comes up because I think there's, again, this, at least with some organizations, some management, a concern that, it should be documented. And in some cases, you see waste occur because people are told to create documentation and they do, even though it's not being that useful. Or in other cases, they create temporary documentation from projects, which is great because it helps people figure out a problem and so forth. But once that documentation has been used in that point in time, it's often of very little value to like go back to 2 years later. And so it doesn't mean it was bad, but it does mean that it doesn't really help understanding the system's current state or understanding the big picture. And then also, what's the technology built on? Is it good technology? Will it work for us? So I think the most important thing with scalability is to specifically define what do you mean by that? Because there's a vague idea that, well, we want to push more throughput through the system. We want more users to be able to use it. But when you get into the details, it's very important to understand what specifically do you mean in terms of scaling up load in the system, and what's the time element in it? Because most systems have to respond to whatever the peak load is, and so getting a handle on what that relationship is versus what specific types of load are you talking about putting on the system is really critical to having a useful scalability conversation. And so many times we need to help bring that into focus during our review process so that we understand what the business wants, which is usually something like we want to be able to grow incrementally. And what you need to do to grow a platform incrementally by, say, doubling the users in 3 years is far different from what you need to, say, have web scale where you have to go 2 to 4 orders of magnitude in a year. So understanding the differences between those and the decisions to be made is very important, because otherwise you can waste a lot of time and money on building something you don't need to build. The separation between horizontal and vertical scalability is very important as well to separate. I think I'm not even sure. I was going to say I'd make a generalization about technical versus non-technical staff, but I don't even think it holds. I think a lot of people just don't articulate specifically what they mean, again, related to scalability. So in the case of vertical, you're throwing money at a single machine to get more throughput out of it, which is valuable. But for most larger scaling, horizontal is spreading the load across multiple machines so they can process it independently. And that allows for, obviously, that's where we get all of the large scale systems that we see today. However, it's not just as simple as that, because there's all sorts of other things you can be doing with processing, especially with the tools and platforms available these days. And you, especially with concurrency and parallelism, in terms of splitting problems up and running them in parallel, or breaking a problem down and doing parts of it with different processing, either on different machines or on the same machine to take advantage of cores. These are all important, but in some cases you may be doing them for performance, not necessarily explicitly for scalability, even though there's obviously a relationship between the two. And so understanding, okay, why you're breaking work up and partitioning it out, and whether you're looking primarily for performance versus scalability is an important design and architecture aspect to have clearly in focus. And then obviously just straight up performance tuning in terms of efficient algorithms, efficient database use, efficient network protocols, and so forth. Performance is generally always great because it improves most systems regardless. And then on top of that, generally some types of performance get you tuning, usually get you better use of resources, and thus more scalability. But there's other types of performance changes that you make can be related to caching, parallelism, or pre-indexing and so forth, that may actually increase the overall performance time or make scalability more difficult in the long term, but which allow you to get higher performance. So again, understanding and bringing into focus with your team all the different dynamics of what you're trying to do are very important. And then a big dynamic we see with many successful systems these days. And I think it's obviously these techniques have been around for many, many decades, but it's become easier to approach them. Is if you can time shift or decouple your processing to handle load, it can be very effective at making best use of your resources and increasing scalability. And time shifting can mean a lot of things, but in general, it's often put together with decoupling. And by decoupling processing, I mean things like a message queue that allows you to separate the processing from, say, a request response cycle from all the different work that needs to be done. And many systems use various aspects of these techniques these days, like sending an email by putting it into a task queue and not trying to send it while you're responding to a user's web request is a simple example. But simple is good, and many systems don't need more than that simple response. But other systems will do many things in time shifting with pre-processing and indexing of data to really essentially go through and look at what needs to be done with data. Can we get it done ahead of time? Google indexing probably being one of the most famous examples of that. So horizontal partitioning for scalability is generally the most interesting for any business that really wants to grow, because it gives you a lot more flexibility in how to use resources. And these days, the database is usually the bottleneck you need to think about, because it's really easy to scale most web app frameworks now. You actually have to go out of your way to build a stateful web session these days and make it difficult to scale load with a load balancer across different systems. We've seen folks do it, and sometimes you may want to do it for specific reasons, sticky sessions for caching performance or whatnot. But in general, that middle tier processing layer is easy these days. The database can still be a potential issue, though, because it's harder to scale horizontally and it takes more work often. However, it's a great example of, if your business is only ever going to get so big, you may be able to do just fine by managing your database partitioning as logical partitions per customer, where you automate the provisioning of the database. There are services now that are available in the cloud that allow you to easily do that. And taking that approach versus, say, trying to build a true multi-tenant from the ground up may be a lot simpler. And if you can write less code and get it to market faster, it's better to do the simple solution than do the more complex solution. So everybody is in the cloud these days. Obviously, that means a lot of different things. In general, I think for many folks, it really just means we are now renting a server versus owning it, and that's fine. But it's important to understand the difference in dynamics between being in the cloud with rented servers. Well, I have to be honest, we actually still see quite a few, well, not quite a few, but we do see thick client systems that are Citrix hosted that are touted as cloud native. I don't know what that means, but they're in the cloud, so it's good. But in most cases, if you are just taking your existing system and moving to the cloud, you can definitely get benefits from operations side, possibly economics if you're small enough, although that actually reverses if you get really big. But for most organizations, being in the cloud is probably going to be cheaper for them to operate more efficiently. But it doesn't magically make your software different. It's still running on servers. Even if you put it in containers and stuff, it's still running. Your software is still built to assume certain processes are communicating with each other in certain ways. So there's nothing, again, wrong with that, but it's important to understand what is it you're trying to do with the cloud. Now, there are interesting developments coming out of cloud, in particular AWS and everybody chasing along after them, related to services. So instead of just renting the server, getting the service, particularly all the various Aurora and Google Cloud SQL and Microsoft and so forth, now have essentially database on demand, which again doesn't really change how you run the make the software. It really changes what nothing about how you built the software. You need to decide that you're going to embrace a cloud service technology like a message queue and build around it, and then decide whether you're going to abstract it so you can move between cloud providers. But that's an interesting dynamic that really, once you start building true cloud native systems, can be very interesting. In particular, taken all the way going to serverless code execution. So key maintainability characteristics that we see in the code size, modularity of the systems, how well they separate concerns. Is there automated testing? How flexible is the code? Is it designed to be, can you change the code's behavior by changing data, or do you need to go in and change a bunch of hard-coded stuff? Extensibility is huge. Has the code been built so that it's easy to create new functionality that doesn't need to copy paste, that can take advantage of existing code? And then being able to see what's going on in the code in terms of logging instrumentation to know at runtime what's happening. So we look at some key metrics, because a lot of, when we're looking at big systems in particular, we have to rely heavily on tools for scanning and code metrics to decide where we're going to look, because we don't look at all the lines of code in a million line of code system in 2 weeks, obviously. So this is one of our the health profiles of a system, where we take the size of files and just rank them versus the amount of code that's in each one. So this is a very simple view that essentially says, are more of the files bigger or smaller? And the and this sort of health metric is generally, we find, because we like to do the quantitative analysis and then back it up with a qualitative analysis. And generally we will find that when we see a profile that looks like this, where the vast majority of the code is in larger files, that the code probably isn't going to look very good on the inside with a lot of other characteristics. Similarly, we look at per routine complexity. We take a couple of different views of this. Over on the right-hand side, we have a typical McCabe type complexity count that we do, which is, we fudge a bit for different types of languages and so forth, but essentially boils down to how many decisions or logic branches are there going on in each routine. And again, we like to see a profile that looks more like this first Z other category, with the majority of code in routines that have smaller complexity versus some of these others that are more on the right. And then the chart below is another view of the size of the routines versus the amount of nesting in them. And again, these charts are set up so that we'd like to see more on the left and less on the right, because it's an indicator of higher modularity. And yes, there's all sorts of exceptions and variations to this, but in general, when you're dealing with hundreds of thousands of lines of code, these profiles are very strong indicators of code quality. And you can go in and spend a week going through the code, reading it and so forth. And generally, we find these to be very predictive metrics. So if we look at some well-known open source projects that we did the same type of analysis on, you'll see these are the type of profile that we see in what we consider best of breed systems. So literally the vast majority of the code is in quite small, modular, less complex routines. And we see that again with various software, where we look at the ones that we think are really sophisticated and they're really knocking down the park in many different dimensions, will tend to look like this. And in most cases, they're not measuring. So they're not measuring this and trying to optimize for it. This characteristic of the system just comes out as the nature of what they're doing. And if you take something like Linux, which has over more than 4 million lines of code in the kernel, you're not going to change that. This distribution is what it is. So if you've got lots of code and you've got a really bad distribution, you're not going to be able to go in and spend a year and rewrite a bunch of stuff and really change that, move the needle on that. If you have less than 100,000 lines of code, maybe. More likely, if it's good to know where you're at and where your risk areas are, but then you just need to have some sort of incremental plan for addressing them, because this isn't something that you can just fix. In terms of, is the code documented? I can pretty much just say no. I don't even have to know what it is, or just no, it won't be. The odds are very small. However, in the old days, you'd see a lot of code that was inscrutable in terms of the code itself, its naming and whatnot. That is extremely rare. We hardly ever see code that is not reasonably self-documenting. There's certainly various levels, but it seems like everyone has decided that it's really stupid to have inscrutable functions, variables, and files, and so forth. Of course, you may inherit old code that has those sorts of characteristics. However, the best systems we see don't religiously say we're not going to write anything down. They combine good code that's readable with some commenting that captures design information, why the code exists, why a module is in place, what are the interesting relationships between this module and other pieces, sometimes an important construction note about why something was done that way. Again, it's not comprehensive, but it's high leverage. And you combine that with some high leverage documentation about how the system works, then that works really well in terms of getting people up to speed quickly. On the flip side, we see organizations that mandate code comments, and the worst are mandated templates and mandated doc comments for automated document generation. Unless it's for an API that's being consumed and someone's actually reading that documentation, it's a complete waste of time. You just end up with a lot of cruft, a lot of repeating the code, and we essentially give no credit from a knowledge management standpoint when we see that, if there's really nothing in there that's not in the code already. One thing we figured out is that people can build anything with any technology. The choice of technology is not as important as people think. That said, obviously it can be much easier to build certain things with certain technology, and it's good to be aware of what's new, but you probably don't want to grab the bleeding edge to build an important app for your business. But you definitely also want to try to avoid being on really, really old technology, because even if it works, at some point, it's not going to be worth the bother, or you're going to be leaving things on the table that you could essentially build more efficiently with in the future. So in terms of what we've seen with best breed organizations, the architecture decisions are the most important in terms of deciding how to structure. Following from that, deciding what you're going to run the system on in terms of operating system, and most importantly, what sorts of frameworks are you going to use for building the applications. And then honestly, what languages you use, that's really not that important. But obviously languages can heavily influence which technology or frameworks or tools are available to you. So they are not unimportant, but people put far too much weight on language in our experience than is warranted. In terms of what's hot out there, it's hard to get good information. I think the best is obviously from GitHub, because everybody's there now. But by everybody, that doesn't actually mean everybody. It means all the open source world, plus a big chunk of the private world. However, there's still a big chunk of the private world that's not checking their stuff into GitHub. So in particular, we note, if you look at this chart from GitHub, that they have C# quite far down the line. And in our experience, there are more people using C# than this. It's just that a lot of them aren't using GitHub to store their code. I'd say we see C# and Java about a similar amount. JavaScript is all over the place, but primarily because it's all over, everybody's got some kind of web UI, and that's going to have some kind of JavaScript in it. We do see Node.js being used more on the back end, and some full stack Node.js systems, but it's certainly not that, for instance, Node.js has taken over Java from our perspective and back end, certainly for business systems and so forth. So to sum up, most code that we've seen They use revision control. You might laugh, but that is honestly, you still can find organizations that don't, but typically it is much rarer now. Again, we talked about it has reasonable naming. There is some attempt to have layering and modularity in the system. There is some type of automated build, it may not be full, and then generally is some sort of release staging where you have people can run full stack on their workstation. There's a test environment and there's a production environment. And most code we see these days have at least had some sort of go at automated testing. But whether they've stuck with it or it was effective varies. So better code we see has very active engagement with automated testing. And in the best code, automated testing is not just seen as oh, we're going to do unit tests, or oh, we got some guy doing Selenium. It's seen as all of the above, and even more, it's we're going to build essentially simulators to be able to exercise our system. And we're going to do it at several different levels. So we're going to write some Selenium code to exercise a web UI. We've got web services APIs. We're going to write some or leverage tools and write code on top of that to randomize input into those and be able to hammer on those in different ways. And we're going to write unit tests that go along with our various code. But usually the best organizations we see aren't necessarily just doing a blind test first approach where just tell the developers, oh, everything has to have a unit test. So when we see that, what we see are a lot of really lame unit tests that are really, I mean, they provide some smoke test value that stuff didn't blow up, but really very little beyond compiling the code or transpiling it. So the best testing really embraces the idea that we are trying to figure out different ways to create simulation to exercise the system and be able to build it into our build process as much as possible. Obviously, the better software has stronger embracing of architecture, layering, separation of concerns. And then you get into more sophisticated decoupling and so forth. And you can look at something like microservices as a pinnacle, but of course it's an engineering decision. So there's always trade-offs between things. We don't, in the best organizations, we don't see a lot of religion about this is how we're going to do things. It's more that they've made certain decisions about what's going to best meet our business goals, and they take advantage of new techniques and technologies that become available. Generally, always the best code shows good profiles on those complexity metrics we looked at. Technology choices that, again, don't cause work, they minimize it. And they are built to be flexible. Now, obviously, you can't build everything to be flexible in all ways because that would be too expensive. But there's been good thought put into where does our system likely going to need to change or expand in the future, and can we invest in that ahead of time instead of just constantly reacting to it. So I want to close out with a quick quiz. So to take this quiz, there's going to be 3 slides that I'm going to go through. There will be 4 to 6 questions on each slide. I want you to quickly read the question and then give yourself 1 point if you think that your organization is achieving this. So here's the first slide. I won't read all these. I'll let you do that, and I'll give you about a minute here. All right, 10 seconds. Okay, shifting to the next page. All right, 10 seconds. Okay, shifting to next page. Okay, 10 seconds. Okay. So again, this isn't at all scientific, but based on our experience, if you scored 5 or more on this test, then we would consider your organization above average. And if you got 9 or higher, then you're doing very well compared to many organizations out there. And again, these aren't necessarily, our viewpoint isn't of all organizations. This is actually of organizations we see through due diligence that are reasonably successful as businesses. So there's a lot of potential room for improvement. Although some of the things in that list may not be a fit for your organization. So we're not implying that they have to occur, but things to think about relative to what we've seen in best of breed organizations. So I want to thank everyone for your time, and we have a bit of time now for questions. And looks like we have one from 80 that there seems to be a big push for microservices architectures. Are we supportive of this approach? Are there other options? So microservices is like the new hot thing. It's the evolution of the service-oriented architecture approaches that go back, again, many, many years. We see very few what I would call pure microservices or even nanoservices systems in the wild. We have seen them, but generally the driving factor behind those systems is massive scalability and decoupling. And the problem is, as you break up your problem into smaller and smaller chunks, you're trading one form of complexity for another. So for most systems, there isn't a need to be what I would call a pure microsystems system, because you're going to incur a lot of complexity and actually processing overhead in having all of that processing broken up and moved around so much. A very interesting dynamic that microservices has popularized is the idea that your database needs to be tied to your service API. That, I think, is probably the most interesting takeaway, because regardless of what the breadth of your service API is, whether it's micro or big or nano, whatever, it's interesting to design your system so that your data stores do not depend on each other outside of the services, because that gives you the strongest decoupling, which obviously gives you benefits around scalability, but it also gives you huge benefits in terms of how you split the work up across teams, and just makes the system easier to maintain. However, again, that doesn't necessarily mean that those vertical service stacks need to be really, really narrow. They can be almost nicely organized monoliths inside of each of those stacks, just as long as they're not coupled to other stacks outside of through the database, essentially. There's a question here about metrics and measures for embedded code. Obviously, most embedded code leverages C, C++, although a lot more Java running on devices these days. In general, we do not see a big difference in terms of the quality metric profile with embedded code versus other types of code. Obviously, you can have some really old device code that is really ugly, but generally good code looks like good code, and it doesn't really matter what languages it was written in, and it doesn't matter so much what technology or what the software is doing. Do we see a correlation between code quality and business success? Sort of. Having looked at a lot of different companies doing this, it's very clear that you can run a successful business on a somewhat iffy code base, and you can have a really great code base, and your business doesn't go anywhere. So I think the business is a much more holistic enterprise, and you obviously need sales and marketing and execution and so forth to have a successful business. I think what the good code and architecture does for an organization is it can make development more efficient. Because one thing that a code base that is lower in quality is going to do, it doesn't mean you can't run the business on it, but it probably means it's going to be more, you're going to be spending more dollars in R&D, and your dev team's probably not going to be as happy either, because everybody knows that they're working on a code that is kind of ugly, and they'd rather be working on something else. So I've been told we're out of time, so thank you. And I believe this will be available online. All right. Have a good day, everyone.